All right, we are back. Welcome to All This Math. This is Professor Parker, and we are back doing some more radical equations or solving radical equations. All right, so let's take a look at what we got here, right? We got the cubed root, because that's a 3, right? Our index or our root is 3, right? The number written inside the v part, that's our root or our index. So this means we're taking the cube root of 3x minus 4, and that is equal to 2. So we want to solve for x. So we want to know what value of x, what number makes this a true statement, right? If there is one. Because sometimes there are equations that just don't have a valid solution, or at least in the real number system, all right? We might have to do a fake number, or not fake, but an imaginary number, which would be the only way to solve certain equations. But let's see what happens. So first step is when we're dealing with radical equations, and how do I know it's radical? Because I see a radical sign. So this is a radical equation, right? We're trying to solve for x. We got a radical sign. So we first want to isolate the radical and then eliminate the radical. Now, this radical is already isolated. There's nothing else over here on the left side besides the radical, right? And what's inside of the radical. So we can skip that step. That's already done for us. But now we got to eliminate the radical. So the way you eliminate the radical is you do the inverse operation. So the inverse of taking the cube root of something is cubing something or raising it to the third power, basically. So watch this. We're going to do, let me see something. Let me use a different color. So, and also I did it on the left side, so that means I also got to do it on the right side. All right, so now what happens is this exponent and this root are going to cancel each other out, or this exponent and this radical sign will cancel each other out, leaving us with the radicand, which is just 3x minus 4, which is inside the radical. So we got 3x minus 4 is equal to, and then we got 2 to the third power. So 2 to the third power is not 6. Let me put that out there. Let me be the first to tell you. It's not 6. That's a common error a lot of students make. They just do the base times the exponent. You don't do that. What this is saying, it's like an abbreviation. Just like some of us have like long names, or what some people think are long, and their nickname is just a shortened version of their actual name. This is kind of like a nickname, right? 2 to the third power, because it enables us to show what's happening in a multiplication sentence without writing out the entire multiplication sentence. This 2 is the number that's being multiplied. And this number tells us, or our exponent, or our power, tells us how many times it's being multiplied, right? Or how many times, not how many times it's being multiplied, but how many times it shows up in the multiplication sentence, right? So we got 2 times 2 times 2. 1, 2, 3. 2 is my base. 3 is the number of times it shows up. 1, 2, 3, which is 8. Again, not 6. So now I got 3x minus 4 is equal to 8. Now I'm going to solve for x. Two-step linear equation. Get rid of the 4, get rid of the negative 4, get rid of the 3, and we done. All right, so I'm going to do plus 4 on the left, plus 4 on the right, because you do the opposite to get rid of stuff. So 3x equals 12. 8 plus 4 is 12. And then I got to get rid of the 3. So I'm doing the opposite of multiplication, which is division. So I'm going to divide this by 3. Again, balance. Do it on the left, do it on the right. 3. Don't mind that noise. That's just a mail carrier. So anyway, 12 divided by 3 is x. Let me see. 12 divided by 3 is 4. I hope that's some college scholarship information for Nassim that came in the mail. We'll check that in a minute. Anyway, so the 3's cancel out. We got 1s. So 1 times x is just x, and the 12 divided by 3 is 4. Don't make the careless mistake and subtract instead of doing division. So x is 4. Now, we're going to check to make sure this is true. So we're going to go back to the original equation. Make sure this is not an extraneous root, because that happens sometimes. Meaning, you go through all the steps, do the math correctly, you get an answer, but then the answer actually doesn't work in the original equation. That can happen. So let's do this. Cube root of 3, replace the x with our answer, because this is saying x is 4. So therefore, we don't need to write x, because we believe x is 4. Minus 4 is equal to 2. Now, treat the radical sign like parentheses. Treat the radical sign like parentheses, and also follow order of operations inside the radical sign. So inside the radical sign, you got 3 times 4. 3 times 4 is 12. 12 minus 4 is 8. So now you got the cube root of 8 is equal to 2. And that's true. That's a true statement. The cube root of 8 is 2. So because we have a true statement, that means this is a correct answer. Because correct answers give us the truth, right? Correct answers in math give us the truth. And in math, we're looking for the truth. That's the purpose of learning math, is so we can find ways to find the truth. All right, so just another example, straightforward example of how to solve radical equations. You know, yeah, that's about it. So yeah, use this video as a guide, but definitely go get some practice. All right, go get some practice. Practice these problems so you can master them, and you'll know how to do how to solve yet another type of equation. All right, I'll see you on the next video. Peace.